I needed more practice on just studying something out of a book. Participants. Researchers often assume that the results apply to people who were not tested. Applying results to people other than those who were tested is possible. However, two conditions are required. First, the people actually tested must be members of the same population of people to whom results are assumed to hold. For example, results are unlikely to apply to children if the participants in the experiments were drawn exclusively from local university campus. Second, a sufficient number of participants must be tested. This requirement has more to do with statistical testing than with the similarity of participants to the population. With any population or any sample drawn from a population, variability is present. When performance data are gathered on participants, the variability in the measurements affect the likelihood of obtaining statistically significant results. Increasing the number of participants, large N, increases the likelihood of achieving statistically significant results. In view of the point above, we might ask how many participants should be used in an experiment. Although the answer might seem peculiar, it goes something like this. Use the same number of participants as in similar research. Using more participants seems like a good idea, but there is a downside. If there truly is an inherent difference in two conditions, then it's always possible to achieve statistical significance if enough participants are used. Sometimes the inherent difference is slight, and therein lies the problem. To explain, here is a research question to consider. Is there a speed difference between a left-handed and right-handed user in performing point select tasks using a mouse? There might be a slight difference, but it likely would surface only if a very large number of left and right-handed people were tested. Use enough participants and statistically significant results will appear, but the difference may be small and of no practical value. Therein lies the problem of using a large number of participants. Statistically significant results for a difference of no practical significance. The converse is also problematic. If not enough participants are used, statistical significance may fail to appear. There might be a substantial experimental effect, but the variance combined with a small sample size might prevent statistical significance from appearing. So, a very low number of participants is also harmful. Harmful in the sense it's not good for research, and very high number of participants is also not good, because then the statistical difference, the significance of the difference is not much. It's possible to compute the power of statistical tests and thereby determine the number of participants required. The analysis might be done a priori before an experiment is conducted. In practice, a priori power analysis is rarely done because it hinges on knowing the variance in the sample before the data are collected. The recommendation again is to study published research. If an experiment similar to that contemplated reported statistically significant results with 12 participants, then 12 participants is a good choice. In HCI, we often hear of researchers doing usability evaluation or usability testing. These exercises often seek to assess a prototype system with users to determine problems with the interface. Such evaluations are typically not organized as factorial experiments, so the question of how many participants is not relevant in a statistical sense. In usability evaluations, it's known that a small number of participants is sufficient to expose a high percentage of the problems in an interface. There is evidence that about 5 participants, often usability experts, are sufficient to expose about 80% of the usability problems. It is worth reflecting on the term participants. When referring specifically to the experiment, use the term participants. General comments on the topic or conclusions drawn may use other terms, such as users. When recruiting participants, it's important to consider how the participants are selected. Are they solicited by word of mouth, through an email list, using a notice posted on a wall, or through some other means? Ideally, participants are drawn at random from a population. In practice, this is rarely done, in part because of the need to obtain participants that are close by and available. More typically, participants are solicited from a convenient pool of individuals, example, members in the workplace, children at school, or students from the local university campus. Strictly speaking, convenience sampling compromises the external validity of the research, since the true population is somewhat narrower than the desired population. To help identify the population, participants are typically given a brief questionnaire at the beginning or end of the experiment to gather demographic data such as age and gender. Other information relevant to the research is gathered, such as daily computer usage or experience with certain applications, devices, or products. HCI experiments often require participants with specific skills. Perhaps a filtering process is used to ensure only appropriate participants are used. For example, an experiment investigating a new gaming input device might want a participant pool with specific skills, such as a minimum of 15 hours per week playing computer games, or perhaps participants without gaming experience are desired. Whatever the case, the selection criteria should be clear and should be stated in the write-up of the methodology in section labeled participants. Okay. Depending on the agency or institution overseeing the research, participants are usually required to sign a consent form prior to testing. The goal is to ensure participants know that their participation is voluntary, that they will incur no physical or psychological harm, that they can withdraw at any time, and their privacy, anonymity, and confidentiality will be protected. Now, we're at questionnaire design. This is what I needed to study for today's class. Yep. Questionnaires are part of most HCI experiments. They have two purposes. One is to gather information on demographics and experience with related technology. Another is to solicit participants' opinions on the devices or interaction tasks with which they are tested. Questionnaires are the primary instrument for survey research, a form of research seeking to solicit a large number of people for their opinions and behaviors on subjects such as politics, spending habits, or use of technology. Such questionnaires are often lengthy, spanning several pages. Questionnaires administered in HCI experiments are usually more modest, taking just a few minutes to complete. Questions may be posed in several ways depending on the nature of the information sought and how it is to be used. Let's look at a few examples. Closed-ended questions are convenient since they constrain a participant's response to a small set of options. The following are examples of closed-ended questions. Do you use a GPS while driving? Yes or no? Which browser do you use? Give him options. The question above includes an open-ended category Other. Of course, the entire question will be open-ended as shown here. Which browser do you use? Closed-end questions simplify follow-on analysis since it's straightforward to tally counts of responses. It's usually important to know the gender and age of participants since this helps identify the population. Age can be solicited as an open-ended ratio scale response seen here. Please indicate your age. Collected in this manner, the mean and standard deviation are easily calculated. Ratio scale responses are also useful in looking for relationships in data. For example, if the same question results also included a ratio scale item on the number of text messages sent per day, then it's possible to determine if the responses are correlated. Is the number of text messages sent per day related to age, etc. Age can also be solicited as an ordinal response as seen in this example. Please indicate your age. Less than 20, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 plus, stuff like that. So those are called ordinal responses. Where is it? I'll get back to that later. Alright, in this case, the counts in each category are tabulated. Such data are particularly useful if there's a large number of respondents. However, ordinal data are inherently lower quality than ratio scale data since it's not possible to compute the mean or standard deviation. Questionnaires are also used at the end of an experiment to obtain participants' opinions and feelings about the interfaces or interaction techniques. Items are often formatted using a Likert scale to facilitate summarizing and analyzing the responses. One example is the NASA TLX Task Load Index, which assesses perceived workload on 6 subscales: mental demand, physical demand, temporal demand, performance, effort, and frustration. A questionnaire on frustration may be presented as follows. I felt a high level of insecurity, discouragement, irritation, stress, or annoyance. Strongly agree is 1, neutral is 4, strongly disagree is 1, strongly agree is 7. The ISO 92419 standard for non-keyboard input devices includes a questionnaire with 12 items to assess the comfort and fatigue experienced by participants. The items are similar to those in the NASA TLX but are generally directed to interaction with devices such as mice, joysticks, or eye trackers. The items may be tailored according to the device and the test. For example, an evaluation of an eye tracker for computer control might include a questionnaire with the following response choices. Eye fatigue. Very high is 1, very low is 7. Note that the preferred response is 7, whereas the preferred response in NASA TLX is 1. In the event the mean is computed over several response items, it's important that the items are consistently constructed. I think that ends my little stint here. Bye-bye.